Hello students. In the previous classes we have discussed what is meant by standard heat of reaction, standard heat of formation and standard heat of combustion. So and also we have calculated the standard heat of formation if a series of reactions are given. Now we are going to work out the problems how to calculate standard heat of reaction from standard heat of formation data. That is one part. Two parts are there, and another part is how to calculate standard heat of reaction from standard heat of combustion data, because standard heat of formation and combustion data are available in literature for many compounds. So using that data we can calculate standard heat of reaction. So the first one is calculation of standard heat of reaction delta HR naught. This is standard heat of reaction delta HR naught from standard heat of formation data. Okay, for that the equation is delta HR naught equal to sigma n delta HF naught of products minus sigma n delta HF naught of reactants. That is when a reaction is given, like A plus B gives okay, anyway we are going to do the problem, example problem. So for all the products, for each product you take heat of formation for each product. For example, A plus B gives R plus S, that is heat of formation of R into its stoichiometric coefficient plus heat of formation of S into its stoichiometric coefficient. Add these two, you will get sigma n delta HF of the products. In the same way, take A plus B gives R plus S. No? So heat of formation of A, that is reactant, into its stoichiometric coefficient in the balanced equation, and plus the heat of formation of B multiplied by its stoichiometric coefficient. Add these two things, you will get total heat of formation of these reactants. The difference is nothing but standard heat of reaction. Same thing here from combustion data also. Same delta HR naught calculation only. If you want to calculate from combustion data, use this equation. Both the equations are similar. From formation data, products minus reactants. From combustion data, yeah, reactants minus products. That is the only difference. Okay. So this is all standard values at standard temperature. That is why here it is written 25 degrees centigrade. Okay. And care you have to take is important note. Whenever you are multiplying delta HF, either for products or reactants, either here or here, you should not forget to multiply with its stoichiometric coefficient n. So here if you see this, now take this example. 2NO plus O2 gives 2NO2. Okay. For this, what is delta HR? Heat of standard heat of reaction. From that, standard heat of formation data is given. Standard heat of formation of NO given, and also NO2 is given. O2 need not be given, that is equal to 0 because it is an element. Heat of formation of element is 0. So now what we have to do here, delta HR naught is equal to, because it is formation data, so that is important. Formation data is given. Formation, heat of formation data is given. Okay, that is why delta HR naught, so here is equal to products minus reactants. Product is 2NO2, so its stoichiometric coefficient is 2 into NO2 is 33.85. Okay, this is a product. Here only one product is there, so only one, minus, that is you can write brackets here if you want. This is completely products minus reactants. reactants here what? 2NO, that is 2 into NO is 90.4 here, plus reactants oxygen, that is 0. Okay, so this value is minus 113 kilojoules per mole. So very simple problems. These are very simple. Just substitution multiplied by this stoichiometric coefficient. That's all. Only thing you need to remember is products minus reactants. If it is formation data, if it is combustion data, reactants minus products. Thank you.